This is your video for section 3.3, and we're going to talk about measures of central tendency and dispersion from group data. So the objectives in this section are 1. To approximate the mean of a variable from group data, and 2. To approximate the standard deviation of a variable from group data using technology. So first we're going to look at approximating the mean. And when we talk about group data, what we mean is that it's already in a frequency distribution. And oftentimes this is the only available data that we have. It's already been summarized in a frequency distribution, or what the textbook calls group data. We don't have the raw data to be able to get an exact value of the mean. And without the raw data, we can't find an exact value for the mean. But if we have the frequency distribution, we can approximate the mean by using the class midpoint as an approximation for all of the data values in that class. The formula for finding the mean from a frequency distribution looks like this. The F in this formula stands for frequency, and the X actually stands for the class midpoint. Again, we're using class midpoints to estimate our data values. So what this is telling us is for each class to take the frequency times the class midpoint, add up all those values, and divide that total by the total frequencies. And remember, back in chapter 2 we talked about how to calculate class midpoints. A class midpoint is just the average of the lower and upper class limits for that class. Let's go through an example of approximating the mean this way. So we have a frequency distribution. Here are our classes over here, and we're going to approximate the mean of the data that makes up this frequency distribution. Once we do that, we've been given what the actual mean was. It was 46.9 miles per hour, so we can compare our approximation to the actual value. So the first thing we need to do is find our class midpoint. So we're going to add a column to our table for the class midpoint for each class. We're going to add another column over here where we're going to take the frequency for each class times the class midpoint. But first let's figure out the class midpoints. Remember, to do this we just average the lower and upper class limits for the class. For this first one, we'd be finding the average of 42 and 45. In other words, we're going halfway between these two values. So we add them together, divide by 2, and that gives us 43.5 for our class midpoint. Now we could do the same thing to get the rest of these class midpoints, or remember that consecutive class midpoints differ by whatever the class width is. So if we look over here and compare our first two lower class limits, we can see that our class width is 4. So we could get our next class midpoint just by adding 4 to this one. Or we could do it by averaging 46 and 49. Either way, the rest of our class midpoints are 47.5, 51.5, and 55.5. Now for each class we're going to take the frequency for the class times the class midpoint. For this first class that gives us 1305, and here are the rest of the values. So in each case we're taking the frequency times the class midpoint. And we've got all 4 of those values. Now another thing that we need for our formula is the sum of the frequencies. So we're going back to this first column and adding up all of our frequencies. That adds up to 80. We also need the total of this column where we multiplied the frequencies times the class midpoints. So the total of that column is 3,808. And to get our final answer, which is the approximation of the mean, we divide the sum of this column, the total of this column, by the total of this column. divide 3,808 by 80, and what we come up with is 47.6. So that's our approximation of the mean. And they did give us the actual mean up here was 46.9, so it's really not too far off. And again, we could have done a very rough estimate of the mean. Remember that we're talking about something that's measuring the center of the data. Looking at our frequency distribution, we can see that the highest frequency class is this first one, and then the next highest frequency is our second class. So we could have guessed that would be somewhere between these two classes. And it's actually about in the middle. It's actually about in the middle of this class. Now we're going to look at approximating the standard deviation of a variable from group data or from a frequency distribution. And this, to do it by hand, is pretty complicated and time-consuming. So we're going to do this using technology. And while we're learning this, we'll also see that you can get the mean as well as the standard deviation. So we're looking at how to use our graphing calculator to do this. This is very much like what we did to find the mean and standard deviation for a set of data. The main difference here is that we have to calculate our class midpoints and put those into one list, and then we have to put the frequencies into another list. So we're actually using two lists this time instead of just one. So the steps we'll go through: first we'll enter our class midpoints into a list, so we'll enter them into L1 in this example. Then we enter the class frequencies into another list. And then again we're going to use that one variable stats function, which will calculate the mean and the standard deviation for us. Here's the example we're going to do. We're using the same example for which we just calculated the mean by hand. So we already have our class midpoints calculated. Okay, we're going to use our TI 83 or 84 to find the mean and standard deviation for a frequency distribution. And to do that, again, we have to put some data into a list. So on the calculator, you push the stat button and just push enter, so it'll take you to the lists. Now notice that we still have the data in here from the last time we used this calculator. An easy way to clear out the data in a list is to arrow up to the top so that the name of the list is highlighted, and then press clear and then press enter. That just clears out the whole list. Now what we're going to do with this is we're going to enter the class midpoints into L1, and then we'll enter the frequencies into L2. We already calculated our class midpoints, so let's just enter those. We had 43.5 for the first class, 47.5, 51.5, and 55.5. There are all of our midpoints. Now in this list over here, and we'll notice I just got there by arrowing over to the right, here we're going to enter the frequencies. So the frequency for the first class was 30, the second class was 26, third class was 16, and the last class was 8. Now that we have both of those lists done, we're going to go back to our one variable stats to calculate or to approximate our mean and standard deviation. So we go back to our stat button, arrow over to calc, and we're going to call up the one variable stats function. Now this is the same screen we had when we did this before, but this time, since we're dealing with a frequency distribution, here we need to tell it what list our frequencies are in. So our values are in L1. We don't have to change that one. To get to frequency list, we either use the down arrow or just enter so that our cursor is after frequency list. And here we want to tell it our frequencies are in list 2. To put in L2, we do second and the 2 button. That puts an L2 there. Now we can enter or arrow down to calculate and then push enter. Now if you have an older model calculator, what would happen is that one variable stats comes up on your calculator screen, and to tell it that your frequency distribution, you actually have to put in L1, L2. So you do second and the 1 button to get L1, and then a comma, and then second and the L2 button, or second and the 2 button to get L2, so that you'll have one variable stats, L1, L2, and then you enter. Either way, you should get a screen that looks like this. Again, this X bar at the top is our approximated mean, and the SX here is our approximated standard deviation. So that's a much easier way to find the standard deviation than by trying to do it by hand. That's more complicated than I want to take the time to show you. Now, one problem with using this method to get your mean and standard deviation for a frequency distribution is that if then later you go back and try to use the one variable stats just to get a mean and a standard deviation for raw data, because you told it that you're using L2 for frequencies, some of these answers won't be correct. After you've used this, if you're not going to use it again right away for a frequency distribution, I would go back to Stat and Calc and hit one variable stats, and where this L2 is in here, just clear it out. So hit clear or delete, and then enter through here.